If you've ever looked at a classroom packed with students of totally different ages, backgrounds, and learning levels, and instantly thought of it as a huge barrier, well, we are about to completely shatter that paradigm today. Welcome to The Explainer. Today, we're diving deep into strategies for successful multi-grade classrooms, the new role of the teacher. We'll be pulling some incredible insights straight from the comprehensive manual, Attention to Diversity in Multi-Grade Classrooms, to show you how to look at these spaces not as a deficit, but as a seriously rich, diverse national laboratory for pedagogical innovation. Let's get into it. So here is a roadmap for this explainer. First, we'll cover the challenge of the teaching role, then neuroeducation and UDL, followed by the transformation machine. After that, we'll look at dynamics like Photo-Voice and STEAM, then dive into the error autopsy, and finally wrap up with the JACS support network. All right, let's jump right into Section 1, the challenge of the teaching role. Consider this staggering statistic for a second. According to Ministry of Education data, over 60% of schools in Nicaragua operate with multi-grade classrooms, especially in rural and peri-urban areas. 60%! So, if this is your day-to-day reality, you are absolutely the vast majority. But here's the catch. Traditional teacher training hasn't always equipped educators for this highly diverse environment. A systemic approach is practically mandatory if we're going to transform these spaces into thriving hubs of learning. And that shift requires a fundamental redefinition of who you are as an educator. The modern multi-grade teacher just can't be a simple transmitter of a single textbook's information anymore. You are a designer of experiences, you're a facilitator of diverse minds, and, most importantly, you are an educational researcher operating right inside your very own classroom, continuously observing, adapting, and designing interventions on the fly. Just picture a rural school at dawn. The room you're walking into isn't just a random collection of desks. It's a dynamic, high-functioning laboratory. When you start to embrace the true competencies of a 21st century educator, every logistical headache suddenly turns into vital clinical data. Every diverse student interaction becomes a blank canvas for pedagogical breakthroughs. It's actually really exciting. Which leads us to Section 2, Neuroeducation and UDL Foundations. So, why do students in highly diverse classrooms actually have the potential to learn better together? It all comes down to the fascinating science of learning, specifically brain plasticity. Your brain literally reorganizes itself based on experience, meaning every new stimulating event modifies your synaptic connections. Universal Design for Learning, or UDL, capitalizes on this biological reality by focusing on three main pillars: multiple forms of representation, which is the what of learning, multiple forms of action, the how, and multiple forms of motivation, the why. Now, when you apply UDL in a multi-grade setting, something almost magical happens. Imagine having students at entirely different developmental levels working side by side. When an older student explains a complex concept to a younger one, it literally accelerates synaptic connections for both of them through peer mentoring. Cognitive diversity is the exact trigger that lights up the brain and accelerates deep structural learning across every single age group. Okay, let's move to Section 3, the transformation machine. This right here is your master strategy for dealing with cognitive bottlenecks. The source material maps out this brilliant, mandatory three-step progression for learning that is deeply rooted in functional thinking. Step 1 is concrete. This is the input, involving physical, tangible experiences and tactile manipulation. Step 2 is graphic, the process, where students translate that physical experience into drawings or diagrams, and only when those first two are fully mastered do we move to Step 3, the symbolic, the output, which is where you finally introduce formal language, math symbols, or abstract formulas. And that brings us to Duval's golden rule. Seriously, burn this into your memory. If a student fails in the symbolic, one must go back to the graphic or concrete level. Think about it. If a student doesn't understand a physics formula, shouting that same formula louder or making them write it 50 times won't fix anything. You literally have to take them back to the drawing board or give them physical objects to play with so they can rebuild that concept from the ground up. Let's look at how this plays out across different subjects. In language arts, the concrete step might be students physically arranging character cards to build a timeline. The graphic step is drawing a flow map of the plot. The symbolic is finally writing down the narrative structure. In physics, the concrete step has students physically pushing a cart and measuring the effort. The graphic is mapping the trajectory vectors on paper. Only at the very end do they write the symbolic output, the actual equation where force equals mass times acceleration. Makes total sense, right? Let's shift gears to Section 4, Dynamics, Photo-Voice, and STEAM. The manual introduces this incredibly effective active dynamic called Photo-Voice.
Teachers literally whip out their smartphones, scroll through their photo gallery, and pick a picture of a real physical challenge they're facing in their classroom. Then, sitting down with a colleague from a totally different subject area, they turn that photo into a diagnostic meme or a news headline. The whole point is to visually identify and analyze those invisible learning barriers that we might otherwise just gloss over.
It's all about making the invisible visible. This visual record becomes such a powerful, collaborative ally. You start to quickly realize that a specific student's struggle isn't just an isolated math problem or a reading problem. More often than not, it's a systemic barrier. And when multiple educators use their distinct pedagogical strengths, they can dismantle that barrier together through highly targeted interventions. To see this kind of transversal teamwork in action with students, the manual poses a real-world scenario. The school has a chronic water waste problem. How do we solve it? Now think about trying to answer that in a classroom where your students are at completely different developmental and grade levels.
Enter the STEAM tornado. Instead of trapping subjects in their own little silos, everyone tackles the exact same problem from their unique angle. Physics and chemistry students measure the flow and pressure of the leak. Language and English students draft up a bilingual awareness campaign. Sports classes look at the biological need for hydration versus wasting water on the court. And mathematics? They're graphing the projected financial and environmental savings. You've just orchestrated a multi-level, inclusive project without alienating a single student. Talk about a game changer.
Moving right along to Section 5, the error autopsy. This is a massive shift in how we handle formative assessment. The old paradigm taught us that an error is a failure, a fault that gets you a bad grade. The new paradigm flips that entirely on its head. It says an error is not a fault, it is clinical data. You are essentially an educational researcher operating in the emergency room of your classroom. Every mistake a student makes is actually a vital symptom pointing you toward the exact pedagogical cure they need. But to perform this autopsy, you have to accurately categorize the error. Is it an attention error, just from simple carelessness or being tired? Is it conceptual, where they genuinely don't understand the rule? Or is it a translation error, meaning they get the concept but are just having trouble representing it? Once you've diagnosed the type of error, you can use generative AI as your co-pilot. You can literally prompt an AI assistant to instantly create a highly targeted 1-minute exit ticket designed to catch and fix that exact error before the bell even rings. By setting up this rapid feedback loop, you're building a comprehensive, holistic clinical profile of how your student thinks. You're no longer just settling for some vague, inaccurate average grade that honestly tells you nothing about their cognitive journey. Instead, you're intervening at the exact moment the learning process breaks down. And finally, Section 6, JACS Accompaniment Network. The source material wraps up with this beautiful vision of the JCX Accompaniment Network. Because transforming education, it's not a solo mission. A multi-grade classroom thrives when it has a robust web of support, not when teachers are left isolated in their own rooms. By sharing these clinical diagnoses and combining active methodologies, educators weave together a physical and intellectual safety net, one that catches every single student. At the end of the day, the multi-grade classroom is absolutely not a problem to be solved. It's the ultimate environment for deep, interconnected learning. So I want to leave you with this final provocative thought. If your classroom is truly a national laboratory for innovation, what experience are you going to design for your students tomorrow? Thanks so much for learning with us today, and we'll catch you in the next Explainer.